So in this video, we're going to take a look at advanced trig equations. And actually, for the first set of problems that we're going to look at, it's more like quote-unquote advanced trig equations. Really, if you think about it, this isn't learning anything new. This is just practicing and applying old concepts to this new material. So what I'm going to do is I've got a set of 5 problems, and we're going to solve each of those 5 problems using the 3 different directions that are commonly used. So without further ado, let's go ahead and give it a start. Solving for all possible values, we've got these 3 problems here. Now, the difference here is in previous problems, it's always been some number equals trig function. But now we have to rearrange it. So what might help some people is to do what's called u substitution. I'm going to go ahead and say that u is equal to sine of theta. This is a temporary change. And what that does is make the problem easier to look at for some people. 2u plus 2. Well, now it's just an algebra problem. The goal of any algebra problem is get the variable by itself. And we do so by following almost reverse PEMDAS, a reverse order of operations. Divide both sides by 2, and we end up with negative 1/2 is equal to u. Here's the different part. U is not u. U is actually sine of theta. So at this point, we need to resubstitute back in. And now it looks exactly like we're used to. So the way we solve this is by taking the inverse sine of both sides. And now the question is, when does sine of theta equal negative 1/2? Well, I know that sine of theta is the y value on the unit circle. So here's negative 1/2 there and there, at 11 pi over 6 and at 7 pi over 6. So now I ask myself, which, if any, of these answers is correct? Well, for all possible values, I know that I'm going to choose both of those answers and add and subtract as many periods as we want to. So I'm going to start by saying 7 pi over 6 plus or minus the period of the function and k. What I need to do now is make a little note and say k is equal to all real integers. And again, this leaves a little note to the person who's looking at my page about what k is. Otherwise, we're just putting in a random letter. So we've done that with 7 pi over 6. Now we do it with 11 pi over 6, plus or minus a full circle as many times as they want. So the gist of this is to do some substitution, which makes our life easier. Really, it's algebra from here up until here. This is all algebra. And then it just turns into the same problem that we were looking at previously. So let's do the same thing over here, do a little bit of algebra. We're going to go ahead and redefine u. Now we're going to say u is equal to cosine of theta. Or if you're not comfortable defining with the same letter, you can go ahead and say some other letter, p. P is equal to cosine of theta. So negative 1 equals p minus 2. Add 2 to both sides. And we end up with 1 equals p. At this point, again, we weren't originally given p. We were given cosine of theta. So writing this little note is not only useful for myself in case I forget which trig function to use, but it's also useful for whoever's looking at our paper. We can't just magically create different letters, they have to mean something. So to solve this problem, I take the arc cosine of both sides, in this case 1, and over here that means it cancels out with the cosine. So this question is, when does cosine of theta equal 1? Well, cosine of theta on the unit circle is the x value, which is right there. So theta is equal to 0, and then I need to add and subtract the period of the function as many times as we want. So in this case, we only have one answer, which is totally fine. There's nothing saying you have to have multiple answers, and really, if you think about it, this one answer is infinite, because this k could be 0, 1, 2, 3, 4, 5, 6, 7, all the way up to infinity. So even though it looks like I'm just circling one thing, I'm actually circling an infinite number of answers. So let's move on to the last of these. Let's go ahead and say, in this case, let's use m. M is equal to the tangent of theta. Why not? It's just a letter. U substitution is only U substitution because that's what we decided to make that letter. So in order to get m by itself, I subtract 4 from both sides, and I end up with -2 equals 2m. Dividing both sides by 2, I end up with -1 equals m. Again, m was not what I originally started with, so I need to resubstitute back in that tangent of theta. In order to solve this problem, I take the arctan of both sides, and arctan of -1 equals theta. So at this point I'm asking myself, when does tangent of theta equal -1? And this usually gives people a little bit of issues. Tangent is the y over x, so it's not as simple as just looking at your x and y values. So you ask myself, how do you get 1? How in the world do you get a value of 1 from that? Well, in order to get 1, that means your x and your y values have to be the same number. So that means we have the same number over the same number. Because we're looking for a negative, they have to be opposite signs. So where do you find the same x and y values? That happens at all of your pi over 4s. Where do you find them that have opposite signs? Well, that only happens right here and right here at 3 pi over 4 and at 7 pi over 4. So pause for a second, make sure you're search for all possible values. Well, tangent is a little bit different. You take one of those values, you add and subtract the period of the function. Period of your tangent of theta is just pi, plus or minus k. And because of that relationship there, 7 pi over 4 is already in our answer. I don't have to worry about writing down my second one because it's already included inside of here. If you don't believe me, go back and watch that all possible values video. Towards the end, I talk about tangent and cotangent. So all of these are kind of the easier version of quote-unquote advanced. So let's take a look at the ones that are even more difficult. So here, you'll notice things are different. What's different about it is now we've got sine of 2 theta in here. Here we've got cotangent of theta over 3. That's what's different about this problem, and that's what's going to cause issues with people. But for now, let's just go ahead and follow the math. Just follow the math. Nothing is different for the first few steps. I'm going to go ahead and substitute, and I'm going to say, let's go with n this time. N is equal to sine of 2 theta. Notice that I'm replacing the whole thing. I cannot just say that it's equal to sine of theta, because this 2 means something. I can't pop it out front, I can't do anything with it. It's protected by the sine function, so I have to keep it inside of there. So 1 equals 2n. In order to get n by itself, divide both sides by 2. I get 1/2 is equal to sine of 2 theta. I went ahead and resubstituted in. In case you don't see it, let me go ahead and not skip a step here. So now we substitute that n back in. 1/2 is equal to sine of 2 theta. And this is where it's really, really important to make sure that you're following the math. Don't try and skip steps or do things in your head because that's where people mess up. We still need to take the inverse sine of both sides. So I'm going to start with that. But when you take the inverse sine of both sides, the reason you do that is to get rid of the sine. So when you get rid of the sine, you're still left with 2 theta. At this point, I always instruct my students to go ahead and solve this part. When does sine of theta equal 1/2? Sine is the y value, so when it equals 1/2 is there and there at pi over 6 and at 5 pi over 6. So I know that this chunk, this half of the equation, has an answer of pi over 6 because we're solving for all possible values, plus or minus the period of sine of theta, k, where k is all real integers. This is why I keep saying follow the math. It doesn't equal theta. It did in all the other problems, but now it equals 2 theta. That's what's different about this problem. In order to solve for theta, you now need to divide both sides by 2. This 2 ends up getting distributed to both sides. You can prove it by saying instead of dividing by 2, multiply by 1/2, or in this case, multiply by the reciprocal. Pi over 6 divided by 2 gives you a pi over 12. Now you've got plus or minus. 2 pi k divided by 2 is just pi k, and that leaves you with theta. So there's that working through with pi over 6. I need to do the exact same thing with 5 pi over 6 now. So 5 pi over 6 plus or minus the period of my function, k, equals 2 theta. Divide both sides by 2. 5 pi over 6 divided by 2, you have to multiply by the reciprocal, and you get 5 pi over 12. Plus or minus 2 pi k divided by 2 leaves you with pi k equals theta. So both of these are the answer. These are the solution to the problem. So notice we did the exact same thing, but we followed the math. Don't leave off this equal sign. There are too many people that get comfortable saying, oh, it always equals theta, so just always enter that theta. But you need to be careful and make sure that you don't ignore that 2. So let's give an example with cotangent. In this case, we're going to pick another letter. Let's go with A this time, is equal to the cotangent of theta over 3. So -2 is equal to 2a. To get a by itself, we divide both sides by 2. And we end up with -1 equals a. Again, a is not what we started out with. A was a substitution. So -1 is equal to cotangent of theta divided by 3. To get to that theta, we need to first take the inverse or arc cotangent of both sides. Now the question is, when does cotangent equal -1? Well, this is extremely similar to the problem we just looked at. We need to know when x divided by y gives you 1. So x divided by y gives you a -1. Well, the only way that that could happen is by having alternating sides, and they have to be the same number. So alternating signs, same number. Well, the same number happens there, 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 and there, but the only places that we have positives and negatives alternating is there and there, at 3 pi over 4 and at 7 pi over 4. So the answer to the question, when does cotangent equal -1? Well, we're going to take just one of these answers, 3 pi over 4, add and subtract the period of the tangent function as many times as we want, and say that equals theta over 3. To get the theta by itself, we multiply both sides by 3. Because of that distributive property, 9 pi over 4 plus or minus 3 pi k equals theta. Again, because it's tangent, we only need to worry about one of our answers. So again, you are more than welcome to prove that this 7 pi over 4 gives you the same answer, but because of that period of the tangent function, you know it has to. So we're going to do the same 5 problems using the other 2 directions that could be possibly given to you. If you believe you know how to do that, then please go ahead and start skipping through this video to find those answers. But I'm going to go ahead and do these with you guys right now. Exactly the same 5 problems, except now we're looking between 0 and 2 pi for the inverses. What I'm going to do differently here to save a little bit of time is I'm going to do the whole problem using sine of theta. I'm not going to do u substitution, because I don't have to. If you're the kind of person that needs to do u substitution, please, please, please make sure that you keep doing it. But a lot of people are comfortable enough with those trig functions that they don't have to worry about it. So I started by subtracting 2 from both sides, and now dividing both sides by 2. And now I've got my trig function by itself. This is a normal problem that we're used to seeing. This is what we learned on. So we take the arc sine of both sides, oops, sorry, not arcsine of theta, arcsine of negative 1/2 equals theta. So this is the question, when does sine of theta equal negative 1/2? Well, as we look through here, sine is the y value, so down here and here at 11 pi over 6, and at, not 5, 7 pi over 6. So our answers for between 0 and 2 pi, well, both of those answers are between 0 and 2 pi, so both of those are my answer, and 11 pi over 6. Now again, for this one, I'm not going to do u substitution. I'm just going to go ahead and follow that algebra. Add 2 to both sides. To get that theta by itself, I need to take the arc cosine or inverse cosine of both sides. Now my question is, when does cosine of theta equal 1? Cosine is that x value, so in this case there is only one answer. Again, totally allowed. You do not have to have multiple answers, it's just available to you. There might be some people right now that are arguing, but you also have 2 pi. Why not 2 pi? And that's because of these directions. 2 pi is not included. Parentheses means not included, bracket means included. So in this case, only 0 is my answer. Looking over to the tangent, in order to get tangent of theta by itself, I can subtract 4 from both sides. And now I can divide both sides by 2. I get negative 1 is equal to tangent of theta. Now we're back at those problems that we're used to. Take the inverse tangent of both sides. We get the question, when does tangent of theta equal negative 1? Back to the handy-dandy unit circle. Oops, excuse me, that was a bad circle. And again, to find tangent, to find where tangent equals negative 1, you're looking for the same x and y values, but alternating signs. So there and there at 3 pi over 4 and 7 pi over 4. Since both of those are inside of 0 to 2 pi, both of those are our answers. So if you look, these are actually remarkably similar to the answers from the all possible values, just slightly different as you go through, which makes sense because you're still looking at the same unit circle, you're still looking at the same values, you're just looking at different ones. You might take one of these or 2 of these. It all depends on what restrictions the directions have set on you. So let's take a look how these might be different for when you've got something else inside of those parentheses. When it's not just the sine of theta, now it's the sine of 2 theta. We still divide by 2, but nothing can touch inside of this trig function. Nothing can touch inside of the trig function because it's protected. So now we're left with 1/2 is equal to the sine of 2 theta. Take the inverse sine of both sides. Ooh, and I actually almost didn't follow my own directions there. I almost wrote down just theta instead of 2 theta. So I'm going to again figure out, when does sine of theta equal 1/2? Well, that happens at 2 places. Pi over 6 and 5 pi over 6. So we now have pi over 6 equals 2 theta, and 5 pi over 6 equals 2 theta. To solve this, I divide both sides by 2, and that'll give me theta by itself. Pi over 6 divided by 2, multiply by the reciprocal, you get pi over 12. 5 pi over 6 divided by 2, multiply by the reciprocal, and you get 5 pi over 12. So both of these, again, are our answers. A lot of people at this point look at these and say, but those aren't on the unit circle. And while you're right that they're not on our usual unit circle, they're not on the standard unit circle, they still exist. Pi over 6 is a very, very small angle that's somewhere right around there. So it still exists, it's just not a value that we're used to seeing, which is okay. You followed the math, you didn't make any silly mistakes, you're good. Looking over here now, we are going to divide both sides by 2. Again, we can't divide what's inside by 2. It's protected by the cotangent. In addition, the whole reason we divide by 2 is to cancel out these guys. So -1 is equal to cotangent of theta divided by 3. Take the inverse or arc cotangent of both sides. And now we can go ahead and say, when does cotangent of theta equal -1? That happens at 2 places. That happens here and here. Because we want all answers between 0 and 2 pi, we're going to give both 3 pi over 4 as an answer and 7 pi over 4 as an answer. So 3 pi over 4 equals theta divided by 3, and 7 pi over 4 equals theta divided by 3. To get theta by itself, we multiply both sides by 3. Three times 3 pi over 4. Remember, these are fractions. When you're multiplying fractions, it's just straight across. So 9 pi over 4 equals theta. There are a lot of people that try and say 9 pi over 12. They're multiplying by 3 over 3. Just 3, though. 3 times 7 pi over 4 gives you 21 pi over 4 equals theta. So here are our 2 answers for this. So this is where we're solving for between 0 and 2 pi for the inverses. So it doesn't matter that this is now greater than 2 pi and this is greater than 2 pi. It says using 0 to 2 pi for the inverses. So as soon as we take the inverses, this is what matters and this is what matters. These ending answers could be greater than or less than 2 pi. That's okay. So last but not least, the exact same problems using only principal values this time. Each and every one, we're seeing something different happen. So I encourage you guys try and solve these ones before me, or at least pause the video and see what you guys can get done. Alright, so since we've seen this algebra happen quite a bit, I'm going to go ahead and say we subtract 2 from both sides. We get -1, divide both sides by 2. So after it's all said and done, we get -1/2 equals sine of theta. Just for the sake of time, if you guys need to see that algebra again, you can go back earlier in the video. So inverse sine of -1/2 equals theta. So the question is, when does sine of theta equal -1/2? Well, we know that it's going to be here and here at 11 pi over 6 and here at 7 pi over 6. Now I look principal values. Well, that means I have to use those restrictions. The restrictions for sine are from negative pi over 2 to positive pi over 2. Ooh, this is where I gotta be careful. 11 pi over 6 is this big angle right here. I am outside of my restrictions. So instead of taking that big angle through there, I'm instead going to use a coterminal angle and say negative pi over 6. If you need a reminder of how to find that, please go back and watch that principal values video that we looked at. I believe I'm also going to have to do that later on in this video, in just a moment actually. So negative pi over 6 is that answer. Again, to save time, I would add 2 to both sides, and I would end up getting 1 equals cosine of theta. Take the inverse or arc cosine of both sides. And now the question is, when does cosine of theta equal 1? Well, that only happens right here at 0. My restrictions for cosine are 0 to pi. And it's good that the only answer that we get falls within that restriction, and we get 0 as our answer. Again, to save time, subtract 2 from both sides, you get -2, divide by 2, so -1 equals the tangent of theta. Take the inverse or arctan of both sides. And now our question is, when does tangent of theta equal -1? Again, that happens at two places that we've seen quite a bit. That happens at 3 pi over 4 and at 7 pi over 4. Our restrictions for tangent are negative pi over 2 to positive pi over 2. This is again where we're going to get that same issue. So 7 pi over 4 is outside of that restriction. We would have to choose negative pi over 4. We're only allowed to do a quarter circle counterclockwise or a quarter circle clockwise. 7 pi over 4 is over 3/4 of a circle, almost a full circle. So instead, we're going to say let's go clockwise pi over 4. So our final answer for here is negative pi over 4. Rewatching that principal values video may help you guys figure out exactly why it is that negative pi over 4. Make sure you go ahead and skip to the end of that video if you didn't watch that whole thing before. It'll give you a little bit of a hint as to how to find those. So here's the last little section here. Again, doing a little bit of algebra first. In order to save time, it's just 1/2 is equal to sine of 2 theta. Now we take the inverse sine of both sides. Inverse sine of 1/2 equals 2 theta. So when does sine of theta equal 1/2? That happens right here and right here. The restrictions for sine are negative pi over 2 to positive pi over 2, which means one that would fit in there is pi over 6. Pi over 6 does fall in between those, so we're allowed to say pi over 6 equals 2 theta. Again, that's the trick with these. Carry down your equal sign. Don't just magically have it disappear then reappear again. Always write down equals 2 theta. Multiplying by the reciprocal, pi over 12 is equal to theta. Let me real quick point out why in this case we were allowed to use a positive number. In this one here, we were looking for when does sine of theta equal negative 1/2. That negative is what gave me the negative angle here. Because this is positive 1/2, we don't have to worry about the negative angle. Positive pi over 6 does fall within those restrictions. Moving on to the very last problem, dividing both sides by 2, -1 is equal to cotangent of theta over 3. Taking the inverse cotangent of both sides, we're asking ourselves, when does cotangent equal -1? Well, just like before, we figured it out. It happens at 3 pi over 4 and at 7 pi over 4. Cotangent is a little bit different. Remember, the restrictions for cotangent are from 0 to pi, except 0 and pi are not included. So we've got little open dots there. Luckily, 3 pi over 4 does fit the bill, and it does fall inside of that restriction. So we can go ahead and say that 3 pi over 4 is equal to theta over 3. Multiplying both sides by 3, we get 9 pi over 4. Excuse me, that is a very nasty pi. 9 pi over 4 equals theta, and that is our final answer. So the whole idea is to make sure that you're following the algebra. If substitution helps for you, please go ahead and substitute. The only thing that you need to make sure you do if you substitute is specify what it is you're substituting. In addition, if you're doing all possible values, please make sure that you write down that k equals all real integers or whatever letter it is that you're using. Define those letters as you put them into the problem so they don't just magically appear or disappear.